Swayam Prabha. Digital India. Educated India.
Four to 5 is 15. 10 plus 15 is still within the maximal coverage, right? So, community 5 population can still go to 3. Community 3. Okay? Right. You will see there. So, this 10 plus 15 is still less than 30. No problem.
Like, image.
Have it. Okay. There is no. Now see, you can see intuitively if this is 40 plus 40, 80. It might be less than 80, but still it will be more than 30. Okay. This is just an example. That's what I'm saying. Now you expand it. You can have 10 more nodes there. In reality, like, you see that, what is the area, coverage, how many facilities we have to open. Okay. So, pardon?
Parameters, not parameters.
No, see, the problem here is we are not creating new nodes here. This problem is out of existing nodes. Like we have many hospitals, okay, but you cannot deploy every hospital for a vaccination administration center. Which hospital to pick as a vaccine administration center? Okay, given constraints are that it is accessible to all around.
In the case of pharmacy.
Yeah. That facility location, we will come. We will discuss that also. Okay. So, if you are, you have to take a decision on given facilities, right? Which facility do you pick for particular cause? Maybe for vaccine administration, right? Or maybe a healthcare facility given. So, probably these are the density points, we want to locate out of this given nodes, we want to deploy the facilities, which one to choose. Okay. Next problem is facility location. Okay. If, which one, right? Here, one more thing is here, if the consideration is only distance, okay, there can be other also. If it was a time, we can solve the same problem with time also, right? So, time constraint, it takes, we can have, the maximal here, the maximal service distance will be maximal service time, right? That it should not take more than 5 minutes for a person to walk, okay? But then, all the units should be time, like, across arcs. Okay, so how does this model look like, In general, if Z is my maximal service distance between nodes I and J, right? What is, let's say this is node I, Ij, they are presenting the nodes, okay? Maybe Ij can be 1, 2, okay? It can be 2, 3, anything, So, and Z is the maximal service distance between nodes I and J. So, what is our maximal? Z is our 30 miles. Correct? This is 30 miles given. Number of customer zones represented by I. We have 9. Now, number of potential sites for locating, this we want to determine. No, number of potential sites for locating here. One facility we cannot locate. Correct? So, that will be 8. Now, covering coefficient which states that whether the distance between ith customer zone and J is less than or equal to Z. Right? Now, if any Ij combination, what Cij tells? If any combination between 1 to 2, 1 to 3, C1 to 4, covering coefficient is that whether the distance between ith zone and jth facility is less than or equal to Z. If this is less than 30 miles, then this is nothing but 1. Otherwise, 0. So yj is binary variable for assigning a site for possible facility location. If that particular facility is selected for new facility location, then it is yj. Yj is 1. Means like, if, for example, in the final result, we have got 3 and 8. So, the result will say y3 is equal to 1, y8 is equal to 1, rest all facilities will be 0. Okay, so this represents that. Okay, now see how model will look like. I want to minimize number of facilities. Correct? And what are the number of facilities? Whether I should open at y1 first facility, second facility up to y9. Right? In such a way that Cij means C11, C12. Now wait for here y. Here y1. C y1. So here y2. So C y2 and so on. If this is greater than 1. Now C11, if you see, it has already captured this thing. Right? So when C11 and Y1. So when, this addition, right, for all i's. So this I have written for 1. Similarly, 2, 1, Y1. Like that we will do, right? So should be greater than equal to 1. So we will write it for I, 1 to m for all. Okay. So that will help us to know which facility y1, y2, y9 should be 1 or 0 and multiply by this, should be greater than or equal to 1. So this is, it will capture the constraint of, it will take care of which facility is less than 30. This should be satisfied. So this way, if you will solve this, you will get the same answer. Okay. So this is the maximal service distance problem to determine the optimal number of facilities, right, given a network of facilities. Okay. So this can be having many versions. Okay. So maybe I'll show you one more relevant problem which we are working on, the drones delivery, in the area of Meghalaya. So what is otherwise it is again a same problem where to locate the drone launch points so that the drones can supply, because Meghalaya, the terrain is very difficult and challenging. Okay. So now the problem of locating, it's the same problem, right? But what is the research issue here is that, we were facing the issue that terrain is not a flat terrain. It's not plain, right? So we're here, there, longitude, latitude is one thing, but we were not knowing that between 2 points if some hill or mountain is coming. So if some mountain will come, the drone has to reroute. Okay. Either reroute or drone would need more lift, right? More energy consumption, then go straight, then it would come down. Now you see that the same problem, but how complexities would be there. That is also same where how many facilities we should designate as drone launch points. Now there we are having more constraints. I'll show you the solution of that maybe tomorrow or day after tomorrow. That, so that the energy consumption, the drones have limited energy. Then energy consumption constraints are captured, the terrain is captured. Okay. So because if more hills would come on the way, we have to deploy more drones, right, to cover that distance. So, right, so the aim there is same, that, if such kind of emergency would come, right, in that kind of terrain, or we name as difficult to access areas, remote areas, okay, then how quickly we can deploy drones to supply the medicines or any healthcare related product, right? So we designated there were 156 healthcare facilities at all levels, primary, tertiary, community level. So there were 156. So out of that, which facilities can be designated as drone launch point? No, highest point will not be able to launch, the drone. Drone needs to be launched, drone needs to be charged. We should have a facility. Infrastructure, we need infrastructure. So here we are telling that, the points, the potential nodes and points are already existing healthcare facilities. Okay. So, but we cannot have 156 healthcare facilities as launch points. So which one can serve? Just like this. Because, points are fixed. Okay. We have to optimize which should be the launch points, right? We use clustering and then we optimize, right? So these are the examples. Now you see here, we have used this. If the distance is less than 30, we are saying this will be 1, right? So when we have such kind of variables which can take only value 0 or 1, we call them binary. Or there can be instances where we can restrict only integers. They cannot take fractional values. So then we call it as integer programming. And this is, if we have mix of both, we call it mixed integer linear programming. Okay, but as of now, you can say we have to have such kind of variables. Okay. So now we will move to another case of facility location problem. I'll come to assignment little later. Yeah. Yeah. That assignment will be again little difficult. I think this this is related problem, right? The p-median approach. So a very similar problem. Okay. We have 6 points whose distances are given. Okay. And we want to locate 2 vaccination facilities. Now, here I know a priori how many facilities I want, right? But now which one I don't know. Okay. Again, similar problem on. Right? You see here? Now you will tell me the difference, what we are trying to do here. Okay. So here I know there are 6 potential sites. And the distance between, now what do we mean by distance? So this is a facility 1. Facility 2 is 20 kilometers from 1, right? Actually it is symmetric only. That's why we have left blank. So from third facility, the first one is 18 kilometers. So we know the distance between the sites or facilities here, right? Now there are 6 points whose distances are given in table below. We want to formulate, we will come to p-median problem, to locate 2 vaccination facilities among the 6 points. So we need to locate 2 facilities. Which 2 facilities we should locate, right? Which can serve, all loads. Okay. So how we can do that? We know the distances between this. Similarly, we will again consider this as nodes, I2 j. Okay, and dij is the distance. Now what is xij? Xij is 1 if point I is attached to median j, right? Here, one thing I want to locate two facilities, another I want to allocate the facilities to. So then that's what will tell us where to locate the facility so that other facilities can be connected to that, or can be accessible to that, right? So whether out of the six existing facility, where should I locate two facilities in such a way that the distance between all the facilities to jth facility. Okay, let's say all node points we can take. J we will take the potential healthcare facility. So which point out of the 6 should be allocated to j is equal to 1? Which one should be allocated to j is equal to 2? So if we want to locate two facilities, we call P is equal to 2. So P stands for how many facilities we want to locate, and P median. So it actually tells us distance wise what would be the minimum distance covered between all these facilities, right, when all node points would be connected to either J1 and J2 in such a way that the total distance is minimized. Okay, so how we are going to do that? Our objective is to minimize the distance. Now, if point I is attached to median J, so we can say that D11 has no meaning when D1, I1, J1, X, I think we should start from 1 to. D1 to X1. That means J is equal to 2. D2 to X22. 3 to X32. And so on. Again, you will find that now I is equal to 2, J is equal to 1. This is done, right? 3, 1. X31 means I have two facilities, J is equal to 1, J is equal to 2. Now this J can be anything out of 6 nodes, correct? So I here is equal to 1, 2, 3, 4, 5, 6. J can also take up to 6, right? But we need to investigate all. So if you will expand, all that. So how it would be expanded? This is objective function, correct? So if J is equal to 1, 1, 2, 3, 4, 5, 6, the distance between all the facilities would be added, correct? What if J is equal to 2 is the facility to be connected with that, plus all facilities with J2, correct? So what is this? This is X11. This will be what? I is equal to 2, J is equal to 1, X21. right? Multiply by their distance. This all. Now, what if j is equal to 2 is the potential facility? Again, 1 to 2 distance, x1, 2. 2 to 2 distance, 3 to 2 distance, and so on. This also add into it. Then what if j is equal to 3 is your facility? Again, what we will do? D1 to 3. Likewise, we will, what is this objective function is doing? Okay. So, if you are getting afraid of what this big formula is, that it is nothing. What this is capturing? 1, 1, this I have expanded here. If you would just go by that expand, this would give us dij, xij summation. We want to minimize the distance. Okay. So, right? And now what are the constraints? Correct? So, when x11 will be selected, this will become 1. That means xjj. When xjj will be 1, that means we have selected that j as the median. It's a point, first median. Okay. Now, if we want to tell the model that you should select only 2 facilities, then what we will tell that? x11 plus x22, x66. This all has to be equal to what? Right? We want only 2 facilities. But which facilities we should have? Which would minimize this distance. Yes? So what else? Yes. Double summation, because we have one summation, we need to expand for all the nodes. Second summation is like, so this is this 1 to 6. When 1 would go from 1 to node 1, let's say, all 6 facilities can be potential node, potential for locating healthcare facility, right? So, I will be all facility location. J we would take 1 by 1 as the potential healthcare. Okay. So, I will take care of the node. J is the median point. What if J is 1? Let's fix J first 1. Okay. If J is 1, let's do change I. Okay. So, likewise, it will enumerate all possibilities of D11, X11 plus D12, X12, D21, X21. It will exhaust all the possibilities. Okay. And it would minimize the distance. Okay. Right. So, but there should be some constraints. What are the constraints? Whenever we are finding median, we are saying this is a P median and our P is set as 2 facilities. Okay. So, we are defining x11, xjj is equal to 1 if point j is a median. So, here my facilities are there. Let's say j is equal to 1 first. Right? So, here it is I. x11, d11. x21, d21. Is this okay now? Here I is equal to 2, j is equal to 1. I is equal to 3, j is equal to 1. What is the distance covered by each node up to facility 1 if we decide facility 1 to be the facility location node, potential healthcare node. So you will add them all. Then we will investigate what if j is equal to 2. First facility x12, d12, x22, d22, x32, d32. This will enumerate the distance between all the facilities and median point 2. So this also you will add, and this also you will add at the end. Okay? So that's why you need two summation. One summation is summing across j, and this summation is across all I. Are you getting now? So we will try to do this up to 6 facility, and here, so we will add them all. So we will get minimum distance. Right? So now you see that this is the power of optimization. If just for 6 facilities, okay, we have to do so many things manually otherwise. Okay. But if we will write it in this format, it is more compact. But we have already, we will see that we will solve this problem in Excel also. You will see how quickly we can and easily we can solve this problem. Fine, we have defined Xij if node 1 is connected to the median point, right? Or we can say if point 1 is assigned to the node 1. Or node 2 assigned to node 1, that means x21 is equal to 1. If it is not connected, it would be 0. Okay. And we have defined xjj. If xjj is equal to 1, that means that is a median point. That is our node point. Now what else we need? We need xij is equal to 1. Now here, one more difference. We need to, in the previous problem, okay, you will tell me the difference. Now what this problem is saying that, suppose this is J facility for us. If this facility, suppose if this is selected as potential healthcare facility, if this is, or another potential facility is say 5, P is equal to 2. If we would assign this facility to 2, this cannot be assigned to 5. That means the nodes can be assigned to potential healthcare facility, only one potential healthcare facility. Okay? Makes sense? Okay? Why we should assign. So then we will have an accurate picture. Now how this is different from previous model? In the previous model, we saw that even the visa connected to 4, 5, even 2 facilities can be served from 3, okay? Now you see that, this all depends on what problem we are solving. If we are opening up a health clinic, where we just want that, patient can come from any node, no problem. But when we have to allocate vaccines and all, right? We really want to stick to this zone can be allocated only to this particular node, right? That would give us some accurate figures, how many vaccines and drugs can be administered. Okay. So now what is this? How we can address this issue of that each node should be assigned to one healthcare facility only. So what is this say? Now again, if you try to expand for all i's, what is xi for all I? Let's say we are talking of all i's. So 6 times I will write. Now what is for all i's? J. ranging J. 1, 2, J11, J12, 13, 14, 15, 16. And there is a summation sign. Add them. This is treated as for all I. For I is equal to 1. Okay. Now this, the first node, and what is J here? J is ranging. Okay. This it has to be equal to 1. What does this mean? Out of all these things, there can be only one. One possible, isn't it? So what does this mean? What does this implies? So one facility, this ith facility is equal to 1 can be assigned to only one healthcare facility. Correct? This is for all I. So that means how many equations we have to write like that? 6. We will write for I is equal to 2 also. And okay. And here we are writing X. Now next constraint is Xij. Okay. This will, now what would happen that, how would we ensure that the healthcare facility which we are selecting, that Xjj. So this assignments which we are doing, this assignments have to be happen only to the open facilities, means the facilities which are designated as potential healthcare facilities. So all Xij, each of this one has to be for all Ij. Okay. So this is very important. So how would they ensure that whatever facilities we are assigning to potential healthcare, the assignment should be in such a way that those would be assigned only to the Xjj, which are Xjj are 1. Okay. This would prevent to assign the facilities to unopened healthcare facilities, means the facilities which are not selected as the potential healthcare facility. So how come X1, 2 has to be less than or equal to X22? If X22 is 1, that means if our second node is selected as potential healthcare node, this has to be either 1 or 0. Okay? That is possible. Suppose if X33 is not a node, turn out to be a potential healthcare node. If this will be 0, then even X23 has to be 0 only, because it has to be less than that. It has to be 0. Not only X23, X13 has to be 0, X43 has to be 0, because if X33, if any JJ will not be selected as potential healthcare, nothing should be assigned to this healthcare facility. Are you all with me? It's difficult, or it's little difficult, but when you will see that, you will understand. Every constraint has a meaning. Yes. No. Xj can take 1 and 0 value. Xjj can be 1 or 0. Okay. If x33 turns out to be 0, what does this mean? Nothing should be assigned to 2 third. Nothing to be assigned means x13 should never be assigned to third facility. 23 cannot be assigned to third facility. Same with 43, 53, 63. So what we are saying, x13 has to be always less than x33. If x3 will be 0, to meet this condition, x13 automatically have to be 0. Okay. So because if we will not give this constraint, then how will we stop the model, from assigning any facility to unopened facility? Okay. So now we are done. Definitely xij can also take 0 and 1 value. And they are binary integer. Pardon? Yeah. No, 0 and 1 is only 0 and 1 would reflect whether if xij, when we talk about xij, 0 and 1 will tell us that whether this ij arc will be connected or not connected. For example, if we will say x12, if this is 0, then 1-2 assignment cannot happen. If x12 is equal to 1, then it is possible. It's just tell that. Now, that's why, when I'm saying D12, x12, if our model will tell that whether 1-2 will be connected, then only it will consider the distance. Otherwise, distance multiplied by 0 will eliminate this term. Right? So, yeah, we will do it in Excel. We will optimize it in using Excel. You want to do it in Excel? We have shared Excel file with them. Data file we have not shared.
You pointed class to get a track on the sharing the data.
I think, do you have you everyone got a laptop? But can they access internet? Yeah. Okay, no, that is okay. You can, it won't take much time.
So, people take the Paula
This is the data problem 2.
expand that for one. It's be from to Paul the next one. Yep, it's what Paul.
Yeah. I think this problem 2, if you do you have your laptops with you right now? This will not take 2 minutes, it will take. Can you create the matrix the same way? A, B, C, D, E, F, G and start with 1. You can input the 1. We can demonstrate Excel solver 1. So we are working on data problem 2. Can you quickly feed this data? But be careful, like, to be on consistency, put, like this only. So start from 1 to 7 and A to G. Okay? So you should have 1, 2, 3, 4, 5, 6 here. Like, now this is the distance matrix. Okay? 20, 18, 14, 16, 12, 22, 18, 30, 36. If you are done, let me know. But before that, they should have solver installed. Check your Excel is solver there or not.
Solver in your data tab. Solver.
That's okay. You can add it.
Option add-ons. You can add the solver.
Yeah.
Whoever has not the solver in the data tab, you can check in option. There will be one add-on. There you can add your solver.
Okay. So after input the data, have you all entered the data? So you have entered the data. Now what you can do is start from A9. Okay, like A9 till G15. Okay. What you can do, the x-axis for B9 you can write 1. B9 to G9 you write 1 to 6. This is the 6 facilities. Quickly you can write B9 1, B10 2, B3, sorry, B9 1, C9 2, D9 3 up to G9 6. You write that. Similarly, A10 1, A11 2, A11 3, this cell you write 1 to 6. Okay. Now this whole matrix, you put 0, 0, 0. Don't go by 1. Okay. Now you know what is this matrix? This matrix is our decision variable matrix. Okay. So when we have any optimization problem, we would be having objective function which we want to maximize or minimize. We will be having some constraints, but whatever we want to determine, that is called decision variables. Now for this problem, what are our decision variables? Distance is given. What decision variables? What we want to find out? Decision variables. Which are open, which are not open. That also. And what is another decision variable? If that is open, which node is connected to that opened facility? So x1 to xij, xjj, these are all our decision variables. Which xij is 1, which xij is 0, which xjj is 1, which xjj is 0. This we want to determine. That's why right now this whole thing you put 0 to start with. Don't see what this is the final result. This everything will be 0. This is the decision variables. This is what we want to determine. You want to join, you can join someone. You can just see how it's working in Excel. Okay. Fine. Right now we have prepared in Excel, right? So just like we have returned, okay. So this Excel will give us the solution. What do you mean by solution? This Excel will tell us whether here 1 should come or 0 should come. This is our Xijs. Okay. Now, what we have to do? We have to first define the objective function. Don't write anything here. Let this be 0.
P10.
Okay. So this is our decision variables. Right now you put all 0 here. Okay. Now, so you go to cell number J2. J2. Now what should be our objective function here? Okay. So here also you can complete the symmetric table. If 1, 2 is 20, 2, 1 is 20, 1, 2 will also be 20. Okay, so this thing, you can finish. Make it symmetric. Okay, now what is happening here? This is 0, 0, 0, 4, 5, 0. So everything you 0, okay? Now what is this one? This whole matrix is nothing but Xij. And this matrix is Dij. Okay? What is our objective function? Go back to our presentation. What is our objective function? What we want to? We want to minimize summation of Dij, Xij. Okay? Now, how we can write that? Here, J2. You can write in I2 objective function. That's just text. But now what we will write here? We will put equal to. Ideally, what should come? The first cell D11 multiply by X11 plus D21 multiply by X21 plus D31 multiply by X31, so on. Then next plus D12 multiply by X1. Okay? Here? Yeah, see here. First you see here. Here what should come? This cell is Dij and this cell is Xij. You just multiply this cell with this cell plus next D21 multiply by its corresponding X21. This is all Dij. What do you mean by Dij? D11. This is D11. This is D21. This is D31. Okay. This is X11, X21, X31. Multiply Dij, D11 with its respective X11. D21 with its respective X21. Multiply this and then add all of them. Now, these are two matrices, okay? Rather than doing that, Excel gives us a very good command, which is sum product. What it tells, if you see sum product here, this function. Can you select sum product? Now what it does, it says array 1. If we will choose array 1, you can actually select this array, comma, array 2, which is Xij. But first put all 0. Close the bracket. Press enter. This is giving us sum product. Means this is doing the same job. It is multiplying each corresponding terms of two matrices and adding across. You can see the selected arrays. But please finish this, complete it. Distance also you can put in all. Can you do that? Right? You can take instructions. So objective function is set. Now, can you add constraints? Constraints are what constraints? Now, can you put this constraints? Summation of Xij across j has to be 1. How can we do that? Right? I would suggest how you can do it. In the cell J6, now let's first put the constraint on P. Okay? Are you getting that? What is our X11 plus X22 plus X33 plus X44 plus X55 plus X66? So here, can you add all? This is equal to 2. Just addition of this. No need to have sum product. Just addition of this all. X11, X22, X33, X44, X66. This has to be equal to 2. P is equal to 2. Our first constraint. This one. Summation of Xjj across all j's will be 2. So, you can just put in J6, you add this formula. I'm repeating, X11 plus X22, what is this? B10 plus C11 plus D12 plus E13 plus F14 plus G15. Here you put just formula. and leave it. It would be 0 for you now. Correct? Now we have to put another constraint. What is that constraint? Go to our presentation. Xij, summation of Xij is equal to 1 for all I. So for all I, which this whole row. Isn't it? Okay. You please now see that. Okay. You can complete at your places. Right? So now this is, now you see here, this one or so for all I is equal to 1. Right? So coming from, for all the facilities, it has to be 1. Right? I think here it should be see what is this constraint saying? Xij means 1 1 2 1 1 1 plus 2 1 plus 3 1 plus 4 1 plus 5 1 plus 6 1. Okay. So yeah, here you see, is it doing the same thing? You just add formula here. Plus, now this you have to do for how many times? 1, 2, 3, 4, 5, 6 for all the 6 columns. That is equal to 1. What is our next constraint? Xij is less than or equal to Xjj. So, you have to put, you see here, this one. So, all these cells, okay, you can put like, first like, X for all Ij. Just first fix J is equal to 1, right? You put X1, 1 less than J, X1, 1, 1. Then you put X2, 1 less than or equal to X1, 1. X3, 1 less than or equal to X1, 1. Okay, so you can put, you have to put only on the left hand side this value, and just, this is just for symbol and notation for our understanding. Right hand side, what it should be, you just put that. Left hand side, you just put your formula, addition. And right hand side, what it is required, we will put that. For this constraint, even right hand side will be the addition, or the value, the formula, or you can say the term. There is no numerical value we are putting. For example, here in this constraints, the first 6 constraints, we have put right hand side is equal to 1 because this is right hand side. Here we will put the Xjj, X1, 1, X2, 2, X3, 3, that we will put. Okay. So now once you have put the formulas here, this is just for our indication. Now we want to solve it. Go to data. Now whether solver is included here or not? Huh? Solver is there or not? In data only, na? No, first check solver is there or not. But, huh? Huh. How much time it will take? Huh. Okay. Now you see here, please pay attention. I will just, this is your homework to finish. Okay. Click on solver. Oh, because, okay. So, You click on solver. So this window will come. This is self-explanatory. Set objective. If you will click on this arrow, it will go there. Select the cell where we have put the formula of objective function. Okay. And again go back here. It will, this thing, change the screen. Now this is interesting. By changing variable cells. Changing variable cells is nothing but your decision variables. The value of which variables we want to find out. Okay. That's a changing value because it will change the solution. If the value would change, your solution would change. This is the decision variable. Now, what are your decision variables? If I will click on that, which are your decision variables? This one, where you have put all 0 to start with. We want to determine this decision variable. Okay. So, you will select all array. This is your decision variable. Go back, select it, go back. Now subject to constraint. Okay, now what are your constraints? You will keep on adding here. Okay, so here you can say add constraint. If you will click on add, you can put this value. You can choose whether equal to, less than, greater than, or whether it is integer, binary, because xij is our binary, xjj is binary. All these constraints you can keep putting here. And here, you can have either value 1 or if you have a formula, because right now it is formula for you. You can add that. Okay. Because I have already included this constraints here. Okay. So when you will add the constraints, that's it. This option you can click, you just solve. When you will solve it, you will get this optimal answer. Okay. This optimal answer is saying the facility 1 and 2, xii, 1, x11, x22. These are the two facilities which can be considered as potential centers. Then 3, 4, 5, 6 can be connected to 1 only. This is giving optimal solution based on minimum distance. This assignment will give me overall minimum distance.
Like what?
They are all connected to facility 1 because it is x13, x14, x15, x16. They are connected to, yeah.
Why not? What?
This is your optimal solution. This problem will give you two facilities.
These are hypothetical data. You can change with real life data. Like some further the data is hypothetical, you can manipulate your hardware. So finally that case is not coming to. Okay, so 2 is not connected with any of the facilities. So if you are putting your real life data, so everything will be like, those are population, data can manipulate.
Given this data, given this distance, data on distance between each node, this is the optimal solution. Okay, so you can cross-verify. You can run your model. Yeah, even I do see, so x11, x22 is 1, but this is 13, 14, 15, 16. This is no, right? No, not 2. This is not, our J is, this is 1, 3. There is something, we have to check the constraints. Yeah, we need to check the constraints. But, you have to solve this problem like that. You have a solver, like, rather than doing manually, you can get optimal solution here. Can you try it, and tomorrow can you tell, are you able to solve it? Okay. Now this will give you, so how answer would look like? Either x11, 22, 33, 44, 55, 66. Out of this, 2 would be selected, correct? And some of them will be 1. Means it will be based on which facility is selected as healthcare facilities. Others will be assigned to that. Okay. So you try it out. You can upload this one.
Probably have one or the apps even PPT also, which are the problem, but formulation at email. So your task is expand those formulations. For one, even the expand also. So try to expand all those formulations and try to solve the next. That Excel file I'm shared with.
Yeah.
One is solved.
No, see, problem 1 is assignment problem. Yeah. No, that is okay. First, let them solve this problem 2. Can you report tomorrow problem 2? Solve it. Try problem 2. You upload problem 2, but these constraints have to be checked again. Okay? Yeah. These constraints need to be checked. But you know how to write the constraints? PPT is already shared with you. This is a problem 2. Problem 2, try to solve with Excel. So we will have your queries tomorrow. Okay? But you see that 6 facilities, you see otherwise, objective function is so lengthy. So many constraints are there. If we have to solve this manually, it will be really difficult. So solver is solving. Now real life problems are even more complex. It's not only 6 nodes. Just take the geography of Chennai. How many hospitals are there? How many clinics are there? How many healthcare facilities are there? Okay. So for that, we need even bigger one. As I've told you, we are working on Meghalaya problem where 156 points are there. Okay. So this is the power of optimization. So all these facilities, when they decided about facility location, the back end, this optimization problem is solved. Okay. Right. We'll meet tomorrow. Thank you.